Hello everyone, welcome back to RareChem Official. Today we are going to discuss about Fajan's rule. If you like this video, please like, share and subscribe. Without delay, let's get started. Fajan's rule states that no bond is 100% ionic in nature. It has some percentage of covalent character which is explained on the basis of Fajan's rule. Polarizing power. The ability of cation to polarize the nearby anion is called polarizing power or polarizing ability. Polarizability is defined as the tendency of anion to get distorted or polarized by cation is called its polarizability. If polarizability is related to cation, polarizing power is directly proportional to charge on cation and inversely proportional to size. Polarizability is related to anion. It is directly proportional to charge and size. Polarization. The distortion of electronic load of anion towards cation is called polarization. Fajan's rule states that no bond is 100% ionic in nature. It has some percentage of covalent character. So, what is ionic bond? Ionic bond is defined as complete transfer of electrons from one atom to another atom, and or one atom is loses electrons, another atom gains electrons. See, one atom loses electrons, one atom gains electrons. That is called ionic bond. If take, see, size of cation is smaller than size of anion. Electrons are present in this anion cloud. See, these electrons attracted by cation, electrons are moving or attracted by cation. Whenever cation attracts electrons towards the cation, electrons are coming this way, this side. Whenever cation attracts electrons towards cation, the anion get distorted by cation, right? See, this electron, whenever electrons pulls towards the cation, the electrons is coming right this way, this side. Whenever this electrons is coming, the anion is distorted, anion cloud is distorted or polarized. Means electrons is coming this side only. Whenever electrons is coming this side, electrons are rich at this side. Means it is partial negative charge will occur whenever electrons pulls towards the cation. Here electrons is more, here electrons is less. So here partial negative charge and partial positive charge will appear. Whenever it attracts towards the cation, it forms like this. Means it looks like a covalent bond, means sharing of electrons, right? So it is like covalent bond or sharing of electrons, right? Some important notes regarding Fajan's rule. Increase of polarization brings more covalent character in ionic compound. Increase covalent character decreases the melting point and boiling point of the ionic compound. If take one example, here cation is similar, anion is differ. If size of anion is increases the covalent character, because whenever size of anion is large, it deformed easily by cation. If take one second example, here negative anion is same, cation is differ. The size of cation is increases, polarizing power is decreases. See, size of cation whenever smaller, it easily pulls electrons towards the cation. So polarizing power increases and covalent character increases with decreases the size of cation. So LIF is greater covalent character than KF. If third one is covalent character increases with either charge on cation or anion. If take SnCl4 and SnCl2, this one has more charge, this one has less charge. So covalent character is greater than SnCl4 is greater than SnCl2. If take CaCl2 and ZnCl2, covalent character increases for pseudo inert gas configuration. Here this is inert gas configuration, this is pseudo inert gas configuration. Means in outer shell has 18 electrons, so it is called, should be 18 electrons, so it is called in a pseudo inert gas configuration. Whenever the molecule has the zinc, suppose if zinc has pseudo inert gas configuration, it is calcium has inert gas configuration. If comparing both, pseudo inert gas configuration has more covalent character than inert gas configuration. This rule is qualitative rule. It can't explain the percentage of character in ionic compound. For example, suppose 70% of ionic covalent character present in the molecule ionic compound, that we can't explain. So it is called, that's why it is a qualitative rule. What it will explain, suppose if take two molecules, this compound has more covalent character than this one, like that we can say, but we can't tell percentage of, we can't explain the percentage of covalent character in ionic compound. That's why it is called, it is a qualitative rule. Covalent character increases the color import increases. Means whenever covalent compounds absorbs energy and it will emit the, after some time it will, whenever the compounds absorb the energy, the valence electrons, it excites from ground state to excited state. After some time it will de-excited from excited state to ground state. Whenever it happens, the energy will release, it will releases it in visible region. That's why covalent compounds increases the color import. Okay, that's all for today. Thank you for watching. If you have any doubt, let me know in the comment box.